This is your bookwork number 2 video. This is continuing where we left off. We are on page 609, and we are continuing raising with a product to a power. So I want you guys to see this example, and again, make sure you're on the right page and follow along. So we'll finish up these examples and then move on to section 10-3. About division. So it says right here, you can use repeated multiplication to simplify an expression like 4m to the 1/2 to the third power. So I like that you guys can see how it's written out 1, 2, 3 times. So it's 4m to the 1/2 with parentheses around it, all to the third power. So that means there's 3 of the 4m to the 1/2, which means if you kind of combine like bases, it's 4 times 4 times 4, because there's 3 of them, and then m to the 1/2 3 times as well. And then it's 4 to the third, which is 64. And m, remember you add exponents, so it's 1/2 plus 1/2, which is 1, plus 1 more half, which is 3/2. You can just add 1 plus 1 plus 1, 3/2. The other way to look at it is right here. This is kind of more of the shortcut way. Rather than writing it out 3 times, you can think about, I always draw an arrow. The third power on the outside is kind of like it distributes to both or all, there could be more than 2, to all of the bases inside parentheses. So notice how now it's 4 to the third power, and then m, you have to multiply. So m to the 3/2. So that is much quicker than going through these steps, but you have to remember this property of exponents. So again, it's kind of like distributing. That third power on the outside goes to every base, which are the bigger numbers. And if something already has an exponent, it multiplies to it. Okay, so here it is in words. To raise a product to a power, raise each factor to the power and multiply. So for example, if it's a, b to the n power, a to the n and b to the n, they both get the n power. And n could be any number, any rational number, and then a and b cannot be equal to 0. So here's an example. 3x to the 4th power would be 3 to the 4th, x to the 4th. 3 to the 4th, you want to work it out. You could use a calculator, or you could just do 3 times itself 4 times, which would be like 3 times 3 times 3 times 3, 9 times 9, 81. So however you want to work it out. And then here's another example. 4b to the 3/2. So the 4 will be to the 3/2 power, and the b will be to the 3/2 power. And then you can simplify using a calculator, or you could work it out by hand. 4 to the 3/2 equals 8. Okay, so here's some examples. I'll do this first got it problem with you, and then maybe the second one also, and then you'll try the third. Okay, so for this first one, it's 7m to the 9th to the third power. So you can remember it's like 7m to the 9th times itself 3 times. But using the property, I would do 7 to the third power, m to the 9 times 3. So that third power, it's like distributing to each base. Using a calculator, let me do 7 to the third, 343. So if I just use this little calculator, I did 7, and then it's this button to the third power. If you don't know what button to push, you could just do 7 times 7 times 7, since there's 3. 343. And then m to the 9 times 3 is 27. M to the 27th power. Make sure you just follow the directions and get the simplified form. For b, it has a negative exponent. What I would prefer to do is rewrite it with a positive exponent. So I would put 1 on top, flip it, and then the -4 becomes a +4. And now don't worry about the fraction part. You just do the same thing. So forget that it's a 1 over that. Just do 2 to the 4th power, z to the 4th power. And then work it out. So I would do in my calculator 2 to the 4th power 16. Or you could do 2 times 2 times 2 times 2 times 2. Just 4 times. 16z to the 4th. So it's 1 over 16z to the 4th because it had a negative exponent. I flipped it. Then I distributed the power to each base and simplified that. You try C. Okay, so you try this, and we will check back during class and see how you did. Notice it does have a negative exponent, so it's like that one, and then you'll distribute it. Okay, so try that one. That's page 609. And then there's a couple more examples on this page. So this is page 610. All right, so let's see. I do want you to try 5 and 6. So you try those and we'll come back at class and see how you do. All right, so now we're going to go ahead and skip ahead to section 10-3. So I'm going to skip to right here. So you guys go with me. This is page 615. Division, properties of exponents. So we will divide powers with the same base and we will raise a quotient to a power. A quotient means it's like a fraction, so it's like division raised to a power. So feel free to look through this essential understanding and this part. So I'll read through it real quick. You can use properties of exponents to divide powers with the same base. So that big number has to be the same, otherwise you cannot simplify it. You can use repeated multiplication to simplify quotients of powers with the same base, expand the numerator and denominator, then divide out the common factors. So if it's 4 to the 5th over 4 to the 3rd, 4 to the 5th means there's 1, 2, 3, 4, 5 fours, and 4 to the 3rd there's 1, 2, 3. And then you just cancel out 1 for 1. 4 over 4 is 1. And then another 4 over 4 and another 4 over 4. And that leaves 2 4s on the top, which is 4 squared. Notice that that's actually just subtraction. If you do the exponents 5 minus 3, it would equal 2. So that's the rule here. So it says in words, to divide powers with the same base, subtract the exponents. And here it shows m minus n, but you have to have the same base. It has to be a 4 and a 4, or an a and an a, or a 2 and a 2. So notice if it's 2 to the 6th over 2 squared, you do 2 to the 6 minus 2. And you can imagine like this one, look at the bottom expression has a higher exponent. That's going to come out to be negative. And then you have to flip it again to make it positive. So what I do on these ones, and hopefully I'll be able to show you in an example, I notice which number is bigger. And then I realize, oh, my x will be on the denominator since the 7 is bigger. And you just have to think 7 minus 4 is 3. Or you could do it this way, which is slightly longer. But the main thing is, remember, if it's division and you have the same base, you can just subtract exponents. So let's do some examples. All right, page 616. So I'm going to use what we just learned, that the rule is subtract exponents. That's the rule here. If you're dividing, subtract exponents. You have to have the same base, though. So here it's going to be y to the 3/4 minus 1/2. So in order to subtract that, I need to get a common denominator for my fraction. So that would be y to the 3/4 minus, I have to multiply by 2 to the top and bottom and get 2/4. Subtract the numerators. Y to the 3 minus 2 is 1/4. And you can leave it like that. All right, and then I'll show you how to do B. They have the same base, it's a D. You just have to subtract the exponents, so it's 7 over 2 minus 3. Remember that 3 is 3 over 1, so in order to get a common denominator, I would multiply the top and bottom by 2. To just do this real quick, I'm going to write it up above. So 7 over 2 minus, that would be 6 over 2. And that, if I subtract the numerator, 7 minus 6 is 1 over 2. So my answer is D to the 1/2. All right, and then you can see they get more complicated as we look ahead. So on C, it's you have to look at the two bases, the k's and the j's, kind of separately. So for the k's, it's k to the 6th over k, but remember that that is a k to the 1. So I'm just going to write that on the side. K to the 6th minus 1 equals k to the 5th, and that's what stays on the top. So remember that even though that k you don't see a number, it's not 0, it is a 1. So it's 6 minus 1 equals 5. For my j's, okay, I'm going to circle them so you can really see it. It's the j to the second over j to the fifth. What I was saying is look and see which one has the higher exponent. That's where that base will stay with the positive exponent. So for the k's, it was bigger on the top. I keep it on the top positive. For the j's, it's a bigger exponent on the bottom. That's where it will be positive. So it'll be j, if you're looking at the denominator, it'll be 5 minus 2. So that would be to the third power. And that's it. So I did that so that I could have like less steps. Okay, moving on to D. If you're ever not sure, you can just subtract to the top and then work out the negative exponents when you're done. So this one I'm looking at, I'm like, ooh, a to the negative third, but then I have to subtract 5. I want to be careful on that one. And then b will be 7 minus 2. I already know that's easy, it's 5. But for the a, let's see, negative 3 minus 5 will equal negative 8. But it's negative, so when I write my final answer, my b stays on the top, but the a will move to the bottom to make that negative 8 exponent a positive 8. And then I'm done. All right, and then E, I'm going to help you guys with E, and then I want you to try the number 1 and 2 below. Okay, so again, what you want to do is you want to think about the x's and the y's and the z's like one at a time, kind of like combining like terms. Subtract your exponents, so x to the fourth over 4, so 4 minus 4. My y will be negative 1 minus 5. And then my z will be 8 minus, remember that there is an invisible 1, 8 minus 1. So x to the 4 minus 4, that's going to be x to the 0. Y to the negative 1 minus 5 will be negative 6. Since they're both negative, you add them up. If you're ever not sure, check with the calculator. Z will be 8 minus 1, so z to the 7th. And now I want to write my final answer, everything all correct. X to the 0 is going to be 1. Anything to the 0 power is 1. So, and then the y is going to go to the bottom, and then the z stays on the top. So I'm going to just write my final answer nice and neat right here. You don't have to put the 1. It's like a coefficient. Remember, 1 times anything is that number. So to write it nice and neat, you write z to the 7th over y to the 6th. So again, the x's don't disappear. Well, they kind of do cancel out. It is the same thing on the top and bottom. It is a 1, though. Okay, so now you go ahead and try 1 and 2. If you want to, pause the video and try them right now. We'll go over them when we get back into class. Oh, also, I don't think we had one with numbers. I'm just looking. If you have coefficient numbers, 12 over 4, just divide it or simplify it. So just think 12 divided by 4, and that number goes on the top. Okay, so go ahead and give those a try, and we'll go over it in class. And then the last thing is right here, page 618. So it says you can use repeated multiplication to simplify a quotient raised to a power. So like in this case, x over y, you can't simplify it at all, but it's raised to the third power. So think about x over y times itself 3 times. But again, it's kind of like you're just distributing that third power to the top and the bottom. And if you have multiple things on the top or multiple things on the bottom, as long as it's within the parentheses, you do raise it to the third power. Remember, if it already had an exponent, you're multiplying exponents. So here's some examples down here just so you can see. 3 over 5 to the third. You can't simplify 3 over 5 because remember, first you do the inside of parentheses. But if you can't simplify it, raise them both to the third power and then simplify it, work it out. X over y to the fifth. Well, it's x to the fifth over y to the fifth. So just look back up here if you need to see an example. If it's ab to the 1/2, it's a to the 1/2 power over b to the 1/2 power. All right, so here is an example, a got it example, raising a quotient to a power. So it's 4 over x to the third. I can't simplify that, but it's squared. So what I do is I put 4 squared over x. So remember, it'll be x to the third, but squared. You multiply exponents when you raise a power to a power. 3 times 2 is 6. The only other thing I have to do is work out the 4 squared, which is 16 over x to the 6th. All right, let's not worry about the reasoning. I don't want this to get too long. Okay, so 5 looks a little complicated with the 3x to the 1/2. So I'm going to help you with 5. 6 looks a little complicated, but I think you guys can try it. After one more example, I think you'll be good to go. So for x or 3x to the 1/2 over 15, I'm noticing I actually can simplify 3 over 15. You always want to simplify the inside of the parentheses first, if you can. So 3 over 15 is equal to 1 over 5. And then x to the 1/2 is still there, and then it's squared. You don't really need the 1, but I just showed it. It would be 1 over 5 for the 3 over 15. 1 times x to the 1/2 is still just x to the 1/2. So the 1 doesn't really matter, and 1 squared is 1. So you could write the 1 or not write the 1. It doesn't really matter. So I'm not going to write it right now. I know 1 squared is just 1. But I do have x to the 1/2, and I'm raising it to the second power. On the denominator, I have 5, and it only has a 1 exponent, so it's 5 to the second power. 2 times 1 is 2. All right, so here I'm going to multiply these exponents. 1/2 times 2, it's going to be 2 over 2, which equals 1. So it's just x to the first power. I don't need to write that invisible 1. It's x to the first. And then 5 squared is 25. All right, so go ahead and give number 6 a try. Let's see how you do. It's kind of complicated with the negative exponent, so I'm actually going to show you a trick real quick. Since you have a negative exponent, it kind of just means to flip from the bottom to the top, from the top to the bottom. I would actually do that first before I even do anything else. B to the 7th over B to the 4/5, and then to the 5th power. Notice that they do have the same base. You could subtract them first and then raise it to the 5th power. So let's see what you guys get for 6. All right, and I think that's it. I don't think we need to do the next page. I was looking at it. So that is it. Just make sure you've got this done, and we're going to meet back into class and go over the ones I said to try.